on the projects that I have done, and I would be giving you certain live photographs of how the projects which we did, and those parameters also will be given to you. So I'll just start with my presentation now. I'll share my screen. I hope my screen is presentable and visible to all of you. Yes, can I get a response?
Yes, ma'am.
Thank you. So I have made up my talk for today, very much pertaining to energy and energy conservation, in such a way that what is the role of sustainable energy in present for an Indian content, and the opportunities that we have as to conserve energy. So that is how I frame my title itself, Role of Sustainable Energy in the Present Indian Content and the Opportunities Given to Us. So myself, Dr. Praveen Angel from Karunya Institute of Technology, will be taking up with this lecture. To give you an outline of what my lecture would be, and you can get an idea that it will be, okay, my voice is echoing. Ma'am? Okay.
Ma'am?
Actually, I heard my voice twice, so that's why I just stopped. Okay, anyway, I'll just proceed. Okay, so the outline of my speech for today would be onto the introduction. I'll be giving you certain drawbacks of the conventional fossil fuels and why and what's the need of going into a renewable energy and what are the advantages. And after which I would be directly moving on to the project that I have done with Government of India. I'll be giving you highlights on how practical my experience I will be sharing with you how this project was taken up. And what are all the safety measures that has to be taken up in a renewable plant? Of course, I'll give you some highlights on the research areas that you could work on, and then I'll be concluding my presentation. So this is an outsketch of what will be there in my presentation for today. Now, basically, I came to know that you're all first year students, and from a physics background, you know what is energy. You would have studied what is PV at least in your 11th and 12th and all those things. But basically, what is energy? Actually, to talk in Indian perspective for our country, energy is the best input which could develop a country. Because of the enormous developments that we have in the country, the consumption of energy is also increasing very fast. And on an average of 1.5% every year, we are consuming more and more of energy. But 80% of this total energy comes from fossil fuels. Fossil fuels means coal, oil, natural gas, etc. But it is our prime duty to use the resources that is freely available. For example, solar is there throughout, water resources is there throughout, might be your nuclear, thermal, all those things is there. But whichever is available on hand, we should be able to utilize it rather than hunting out for something which is not available. Now, this coal and oil and natural gas was enormous, but as days pass by, this is also fading. So we have to move into the next. We can't still keeping on telling that energy is not there, energy is not there. Instead of putting our hands on someone else, we just turn it back to us of what we can do to increase this production of electricity. Now, what is the actual drawbacks of fossil fuels? These coal, we have used for more than 100 years, we have used, and it is high time that we have to think on some other resources. And oil reservoirs, it is around estimated to be just for 42 years, I guess. Gas reservoirs is estimated for 60 years. Now, this much is the lifespan for each and every fossil fuel. Now, after that, even you want to dig it and take coal, take oil and take gas, where from it will give? it has a limits, right? So we have to move into the next one. And of course, because of this coal, oil, and gases, if you keep on using it, it will be leading to lots of pollution. And of course, it will lead into greenhouse effects. So it is our prime duty to concentrate on a different renewable energy resource in a way to conserve energy as much as possible. Being said the drawbacks of the fossil fuels, I would like to highlight on the advantages of the renewable energy. Of course, there will be no pollution, no harmful effect, no waste products are given, and it reduces the cost of operation also. And it is inexhaustible, that could be got any time. It will not exhaust. I say, right, coal is for this period of time, gas and oil and all those things. But this won't exist. The solar energy which we have will never exhaust. So this slide is just to give you a basic idea about what are all the renewable energy that is available: solar, wind, hydro, tidal, biomass, geothermal, and so on. But in my presentation, I would be highlighting on the hydropower, because when you have heard about my introduction, you heard that I have been involved in few government projects. And I personally felt that rather than talking about solar, wind, or whatever it is, I would like to highlight on hydro projects, which I have worked on it, and how energy could be conserved by using these resources. Before that, I would like to give you certain energy demands that is there in our country. If you see the graph, in the year 2040, okay, in the year 2040, the increase is 333% increase of energy demand is required for our country. All the statistics which we are telling here, I mean, this slide is for the worldwide, but whatever statistics I'm presenting in my slide is as a country as a whole, because we are all citizens of India. We proudly say that. So I've taken different statistics to talk about the Indian scenario and the Indian energy demand and how to conserve energy for our country. So the power capacity, we have added a lot in India. We have really added a lot in India by wind, solar, and a few other small renewable resources also we have taken it up. I have just taken the statistics for the year 2018. If you hear for 2018, we are having coal only 25%, wind was only 12%, solar was 50%, but the renewable energy utility was 74%. So we were able to have an additional power capacity higher because of this renewable energy. All these things is not told by me. I have just drawn the graph, but these are all statistics. You can Google, you can see Wikipedia, and all these things I have just projected in a slide for you to get an idea what is it. So none of the data which is given here is exaggerated. It is all exactly as per the statistics of Indian government data are taken. Now, being said about the advantages, disadvantages, we want a maximum customer satisfaction. And how to achieve it? How to conserve this energy? I'm talking about energy is required, but how to conserve it, ma'am? If that is the question that is rolling, and few of you might have a doubt, like, we want power for all. The country should be self-sustained with energy resources. We should not go in and ask someone else for energy. So we wanted energy for all. So if that is the question, here comes the answer. Eyeing on the silver lining of certain points, how to achieve it could be through generation capacity, improving the generation capacity, improving the power quality, metering methods, so many deregulations, distribution generation, automation, so many aspects are there. As an electrical engineer, I am putting it forward to you. But our point of discussion today is on energy conservation is one of the major factor which could be taken up by any layman in the country to see that everyone is happy with the maximum power. So energy conservation is the major parameter. We have so many electrical parameters as listed down in my slide that I've shown to you, but energy conservation is really important to make India economically strong. Okay, so now then I have told you certain requirements of why energy is required. I've just given you a few highlights about the renewable energy. All these things you might know, right? Okay, now I'll give you certain statistics of history. What are all the accidents which had happened all before years? Not only the accidents, what are all the issues faced and how we are going to rectify it? I just took this analysis when I had to prepare these slides for the presentation. I was really doing a very long survey to find out what are all the hazards taken up and how I'm going to give a solution for all these things. Way back in 1930s, we normally say, can anyone say what is the frequency level of our supply, electricity supply? Ma'am, is students given the provision to unmute their microphones?
Yes, ma'am. They can unmute and answer, ma'am.
Okay. So anyone, if you know, you could answer. If you don't know, also no issues, not to be bothered about it, because whatever I'm going to ask you has something to show onto the presentation which I'm presenting. So that is the reason I'm asking you. So I know you're all first years, but you're all smart enough because you have studied your physics in your 11th and 12th and 10th board, and that is how you are into a very good institution now. So you're strong in your basics. Now, what is the supply which is there? What are the two different types of supply? Supply, what are the two different supply? How do you say power? Okay, there are two different AC and DC, alternating current and direct current. What is the supply which is coming into your home? We can talk from your home. You have a board at your home, right? What is the supply which is coming? Is it AC or DC? Anyone, students? You can even post in the chat box if you know the answer. Anyone who know the answers? Is it AC or DC? Okay, I'm having some chat messages. Okay, very good. The answer is AC supply. Very good. Very good. Now, 3, 4 of you have answered. Now, what is this AC supply? What is the voltage? I'll give you options. 250 voltage, 440 voltage. What's the volts that is coming into your home? What's the voltage that is coming into your home? Option 1, 240 volt or 440 volt. Any guesses? 230 volts. Very good. Smart answer. Going to the next question. What is the frequency level? You have told it is AC. You have told it's 230 volts. Good answering is really good. Priyadarshini and others. What is the frequency? 50 hertz. Very smart. Okay. My question now to all of you is, you might have your siblings or uncle, aunts residing in foreign countries, and they would have got you some electronic gadgets such as mobile phones, whatever it is. Okay. Are you directly able to plug the mobile phone onto the charger pin? I want the answer. Are you directly able to plug the mobile phone that your brother gets from US? Are you directly able to plug it into the charger of India? Yes or no? Waiting for responses. I'm seeing the chat, or else you can speak also. Yes or no? Can you directly plug in the electronic gadget that your well-wishers get it from foreign countries? Iron box, or mobile phones. No one gets iron box, right? But at least mobile phones they would have got from outside. Are we able to plug in directly? Yes or no? Fast. Make it fast.
Students, kindly unmute yourself and answer.
Okay. They are doing it, ma'am. They're all very smart enough. Thank you. Abhinav says no. Yes, you are not able to plug in. But you are putting something in between, Abhinav, and you are connecting it, right? You're putting something in between. I'm seeing your chat messages, students. So if you're not okay to unmute, you can also chat, but it will be really very good if you could speak out, because these are all general things I'm asking you, nothing very tedious and not to put you down. So you need not feel embarrassed if you can't answer also. So Abhinav says, no, you can't plug in the mobile directly, which you got from US. Rather, what you're using there, Abhinav, in case you want to charge it, what you're using there? Abhinav, can you unmute?
Ma'am, some kind of connectors.
Wow, very good, Abhinav. Any other people guess what sort of connector it is? What is there in between? Mobile phone is here, plug is here, but something in between is there, which is going to connect this and this. That is called as adapter. Okay, anyway, thank you students for those responses. Abhinav said, right, we are going to something is there between these two. It is called as adapter. What is that adapter going to do? Is it going to adapt between US and India? It is going to adapt to the frequency level, because the frequency which we are having in India is 50 hertz, as people said in the chat box. But what frequency we are using in foreign countries is not 50 hertz. They're using a frequency of 60 hertz. That is called as power quality. That is called as power quality, which I am talking about in my presentation. The next 2-3 slides will be on power quality. So the frequency, if anyone asks you, please respond them. Okay, next time onwards, if anyone asks you why is that you're not able to connect, the frequency level is entirely different, and that is the reason when you get a mobile phone from US or UK, you can't directly plug into it, because our frequency level is only 50 hertz, but their frequency level is very higher of 60 hertz, and they don't have power failures at all. Very rare power failures are there, but I have found out few statistics wherein they also had a power failures, which I'll show in my slides now. Now coming back here, in 1930, there was a main problem of light flickering due to mass production in machineries. In 1950, there was a problem because of the air conditioner. Air conditioner is a heavy energy consumption device. Okay, I'm coming into energy one by one. I'll come into it. In 1990s, the main problem was because of using electronic gadgets, computers, microelectronics, and so on. In 1996, December, I think it was December 13th or so, I'm not very sure about the date, but in Scotland, December 1996, the power supply was interrupted for 3 to 6 days. Normally, we say only in India, power supply is there, power supply is there. No, India is taking care of us so good that we should be proud to say that we are citizens of India. With this much of population, we are doing a conservation scheme. The government has put up different conservation scheme, and that is the reason you and me are seated like this on an online mode with no interruption in power supply. Okay, so it is not that we are not doing, we are celebrating this day actually. When do you celebrate your birthday? For which you are happy. So we are happy today that India is onto a good forward move on energy, and that is why we are celebrating today as the Energy Conservation Day. Now, the data and the statistics which I'm putting down here is not to put down at another country or anything like that. I'm just trying to project to you that India is doing an energy conservation, which could be improved by citizens of India like you and me in future. That's what I'm trying to project to you. Coming back to this, so when I was just browsing and seeing, is there any issues on December, since we are in the December month, there was in Scotland, December 1996, there was an interruption for 3 to 6 days. They had an interruption, and wherein more than 60,000 customers were affected because of this, and lots of steel towers were damaged because there was not power supply. Lots of accidents took place in that place. Even in New Zealand in February 1998, in Auckland, for a period of 3 weeks, they had power failure. And in California, the blackouts in the Silicon Valley of California was realized that the chip fabrication industry is very sensitive to this power quality problems. And one was in the Canada in August 2003, at the height of ice storms, more than 3 million customers were without power for 4 long days, which sustained for a severe wind, which was greater than approximately 20 kilometers per hour. And this had lots of issues in Canada in 2003. There is a small diagram that a picture that I've taken from Google to show you. So that is about country statistics. Come to our country. In January 2nd, 2010, northern region, that is the Himachal Pradesh, Jammu Kashmir, Chhattisgarh, all experienced a very bad interruption at the night of 2nd January. And it is because of the dense fog, which was mixed with pollution actually. which was the reason which failed at the strength of the insulators and increased the conductivity along the surface of the insulators, and flashovers took place, and because of that tripping was there. All these things is a little bit of electrical, but I just wanted to tell you why that happened. Now, dense fog mixed with pollution was the reason behind the issue that took part in Himachal Pradesh in India. We can't analyze what happened outside the country, so that we can analyze what happened inside the country. This pollution is because of whom? That is a big question mark. I'm not going to give you an answer. Can we reduce this? That is conservation of energy. You can't, because you can't directly take energy and put it in a different box and hide it. No, that you can't do. But you can do a better conservation of energy by giving your inputs to such sort of issues that has been taken place. Coming back this issue which I was talking here, it has been observed that whenever temperature is low, that is between 9 degree and more than 90 degrees, some sort of smog, that is fog, okay, takes place, which will be causing flashover. This is an analysis that they have done. And this evening peak, evening peak hours of 1st Jan 2010 were very normal only. But however, because of this ambient temperature, it was observed in that region, and such atmospheric condition was witnessed for the first time during that winter season. And this was the reason which gave into fog and smog, and it tripped the transmission line very badly. And this was the reason behind it. So now I've just given you in a history what happened in California, what happened in Himachal Pradesh, and all these things. But there is a difference between saving power and save a lamp, that is save 1 ampere, and lowering the power bill. This is a big questioner or big point that it has to be interrogated and thought about. Now, since we are talking about energy, as I showed in my previous slides, there are lots of energies. I would like to touch upon on hydro energy, because this is my work which I have worked on. So rather than giving other details, I find convenient, and my data would be really apt if I talk about hydropower. Okay, any questions, students, until then? Now, what is hydropower? Hydropower is actually, it is a proven renewable energy resources, and it requires relatively high initial investment, which I accept, but has the advantages of very low operating cost and long lifespan. Now, government have given a lot of subsidies even for solar plants. We can generate solar, and we can even give it to the grid. They even give us a subsidy. But the reason why we are not taking up with these renewable resources is the initial investment is very high. But renewable energy, initial investment would be high, but course of time, the advantage or the economical status would be really surprising. People who don't know about all these things, a layman can talk, but those are into field. You and me are educated. We know what is energy. We know what is renewable resources now, as of now. And in course of time, you will be studying more about it. So by the time you finish your third year, when you finish your degree, you should be able to give something to the society in terms of your projects at least. What sort of projects you can do? You can do a material change in the solar panel. It is physics. You can do some sort of material change in the machineries. If you're having an induction machine, you know induction machine is using what coil, students? Just to see whether you are there. A motor has what winding? What is the material used? What is the material use in a motor? You can post it in chat box also. You have electrical motors, induction motor, DC motor. What is the material used for winding? Is it gold that is being used for winding? Or what else it is used? Responses, please. Just to know that you are there with me for the presentation. What is the material that is being used? Okay. One response at least? No one knows? Just a general knowledge question only. This has nothing to do with us. What is the material that is used for any machinery, a small DC motor, induction motor? What is the winding material that has been wound?
Ma'am, copper.
Very good, smart. Thank you for the response. It is copper, Abhinav. Okay. Aluminum also they are using, but earlier days aluminum was used, but the heating was very high. The machinery itself gets heated. But nowadays, you know, the research, they don't even use copper. They are using materials, different nano materials is being used. Even for the solar panel, you know, solar panel is made, silicon material is used. They use different materials wherein the photovoltaic system itself on solar, it could be made more energy. Now, all these things are energy conservation only. So you have a vital role to be played to do energy conservation. Coming back to our presentation on hydro. Hydro projects, basically, we have different types of scheme. When you go for an outing with your parents or for any tour, you would have witnessed all these things. A runoff river, canal-based, dam-based scheme. What is runoff river? At my place, and you also would have behind your home if any stream is going. Even in Karania, we have a stream, a very big stream. Karania, it has been situated in the Western Ghats near Sirwani. I don't know how many of you know. We have lots of streams. When we step outside the window and when we go and see, we see the waterfalls from the mountains, natural stream. There, the waterfalls come. We are not going to stagnate any water. We will put a turbine, which is a powerhouse there with a forebay and tail race. You can generate electricity. The water will be coming, rotating, generating electricity, and it will be going outside. Even the place where I'm seated now is the Tripoli Department of Karnia University. We have solar panel onto the rooftop. We have windmill onto the rooftop. All these things is energizing our laptops, our computers, our fan and light in this room. So what I'm trying to say you is it is a runoff scheme. Here in this hydro project also, it is a runoff scheme. Okay, so you're not going to stagnate anything. You can see a runoff river scheme wherein the river is flowing onto this way. We are just taking up that water. We are just generating it, and again it is going back. This is just a photograph which I have taken from a site here. You can see the water which is coming from different streams here, and all these waters fall into this powerhouse. Electricity is generated, and again it goes back. We are not stagnating any water. That is one scheme. Canal-based scheme. The water which has been run in this, which has actually should be run in this direction, we are just taking a spillway and taking it on to a different diversion as a canal, wherein we have a powerhouse here, electricity is generated. Quite simple, right? This is canal based. We have dam based. I think all of you know what is a dam. A dam is on the head, onto the pressure, which has been fall down. Now the water falls down at a very big height. From 90 to 100 meters head, we call it as head, 100 to 90 meters head. And when the water is falling at a very high pressure, this pressure is converted into energy. Okay, being said this, I'll just give you an example. I think long back in the newspapers only I read in Bombay or Pune, a student, okay, a college student, it was 20 flat apartments in Bombay and Pune. They reside in apartments, right? So that 20 floor apartment, when it is, we do rainwater harvest, right? So that rainwater is collected from the terrace, and directly it comes and falls to the ground wherein a turbine is there. And this turbine comes and this water comes and falls down, and it is in a big distance is more, right? 90 meters, 100 meters or 200 meters. Just assume 25 floor apartments means the water comes in a high speed, comes and touches the turbine, electricity was generated, and that student was able to electrify his wing. What to say, his wing at it. He is living in some floor in that apartments. He was able to electrify the lights which was onto the corridors. See what sort of project students are doing. Did you hear about this anywhere, students? Did you hear about this? Yes or no? Have you heard this? Read in the newspaper? It is an hydro project, actually, to talk about, not dam project. but it is the concept of a dam. The water, when comes and falls down on high pressure, hits the turbine, energy is generated as electrical energy. This is an hydro project. Yes, you can also do at your campus if you're having 5 or 6 floors. Rainwater harvest, rather than directly coming and falling into the ground, you can just put a turbine there, very less cost. You can generate electricity, and you can even electrify the wing, your block, your physics blocks could be, at least the outside lights could be done with this. This is energy conservation. You need not go and conserve energy in Jammu Kashmir or in Kanyakumari. You conserve energy where you stay. I should conserve energy where I stay. That is energy conservation. And one more project would be it is on Hall effect sensors. Since you're physics students, here in the college, outside the college, it is on a highway. Okay, so lots of vehicles passes by, lorries, big trucks all passes by. So what these students have done is on the bumpers, speed breakers, beneath the speed breakers, they have got this is sensors. I think it is Hall effect sensor. And every time this vehicle goes, you just imagine on a highways road, how many vehicles will pass by on one day? For 1 hour itself is more. So this friction energy, every time it moves onto the sensor, this friction energy, they observe it and they convert it into electrical energy. This is conservation. Rather than saying, oh, our college is in the highways, lots of vehicles going by, see the student, how he has done a project. I think by this time I would have told 3 to 4 projects to you. So if you are really interested on projects of energy conservation, please take it up. It is physics, it is science. Okay, you can even note down, because now and then when I'm giving the presentation, I'm giving you some project topics. So all these things you can compile it, note it down. And if any help required onto your projects in future, when you're there in your third years or final years, you can even contact me through your faculties. You can contact me and I'll be really happy to help you out. Okay, moving down here, I told you about this project with the student I've done in Bombay, right? It is just a pico project. Pico project means less than 5 kilowatt is pico, more than 100 is micro. Mega is mini project, mini hydro projects. Small means 25, medium means 100, large means above 100 megawatts. And all these dam projects comes under 100 megawatts. We are not asking you to do any megawatt conservation. Do some 5 kilowatt conservation. This you can very well do. Okay, rainwater collected comes and falls onto the turbine, you can very well do. So what is this small hydro power? Normally it is a runoff scheme. You and me can't do a dam immediately today. Of course, you can do it in future. You can very well do it. But as of now, do small conservation with this hydro projects, which I explained to you right away now. Okay, which is not expensive, it does not require transmission line. You can just use small pumps, turbines, small motors, and you can just keep moving. Okay, now you can have the statistics which I have just shown here, the statistics of Indian statistics year wise. I've just shown till 2017-18. You can see that hydro projects are fading. Hydro projects are very much fading, even though we are having floods here in the country. In some parts of the country, there are even floods. We don't have proper place to hold that water, and the country is flooded. Rather, if you and me could think over on using this God-given natural resources, it will be really useful for us to have a very good energy conservation. If anyone is interested on to start up with an HSP, HSP means small hydro projects. You have a few civil works and you need to have few equipments as shown in the diagram in the slide here. Normally I take this for civil engineers and for others, but since you're all first years, I felt like I should not go into deep into it, but you just know if you want to do an HSP, all these components are very well required. And this is just a schematic sketch of the HSP, wherein you have an inlet, and this inlet will be through from the river. This is the river, okay? The part of the river you will be taking it. There will be an inlet, wherein you have a forebay. Sometimes you call it as a surge tank. This long, lengthier portion is only the penstock, and then it goes and hits the turbine. So this turbine, wherever it is there, that is the powerhouse, okay? And then you will be having an tail rise. Even now, if you go to Ooty, Paikara is there. It is an hydro project. Anyone have witnessed Paikara hydro projects? You would have gone to Ooty, right? All of us are staying here down. So some of you have gone to Ooty. Next time when you go there, go and look out for this penstock. This was done by Indian people. This tunneling, they're actually drilled into the hills of Ooty, and this penstock tunnel is being created. If you have a time, I even took my students to Paikara Falls in Ooty. It was excellent. As you go as a student, if you go as a tourist person, I think you will not be allowed to go as an industrial visit to that place. It is really amazing. They took us till this down part. See, till this water level is there now, till this part we were took, all of us were standing here. All of us were standing here and witnessing. It was amazing to see the water coming on a high pressure, touching those big turbines and going out to the river again. We are not stopping anything. So if you have a chance, go for an industrial visit. So I think I told you 4 projects till now. And the 5th one is I'm encouraging you to go for an industrial visit to witness this hydro projects, because big dams, even this different dams that has been constructed, dam construction is excellent in our country. If you have time, when you go for an industrial visit, you please have a look on all those things. So this is just a schematic sketch of the runoff scheme. You can see the water flowing, taken up with this powerhouse, and it is back into the river. We are not keeping any water to ourselves. We are just making it up. So runoff river scheme is very easier. This could be done as a project. Behind our college here, as I told you, stream is flowing. Our students, that running stream has put turbine. We have an aeronautical department, so we have different aeronautical blades there, and the power consumption was really good. So they did a centrifugal water rotation. The water is coming to the rivers. They made it as a centrifugal rotation, so that why I have to do this is the pressure will be high. When the pressure is high, the energy that is being generated also will be really high. So that is also yet another project that you could do. Now, coming back to the basic equations of power, or else we call it as potential energy. Power is given as the product of density of water, discharge, acceleration, the head, and the overall efficiency. Head means the distance from where the water comes and falls down. I showed you in the dam, right? That is the head in meters. And for a good HSP, for a good small hydro projects, the efficiency of the hydro project depends upon the efficiency of the turbine, efficiency of the generator, and the gearbox. So average efficiency is around 75 to 80%. If you want to do an energy conservation projects on hydro, you must have a preliminary feasible report, you must have a detailed project report, and then you move on to an execution. Even when you want to construct a home, you can't go and construct a home right away there. You have to even check the sand level. You have to check the rock. If any rock is there, directly you can't go and put an house there, right? If you do that, when water comes, your house also will be taken out. So that preliminary feasibility report is very much required for you to start up with any projects. So I just started with energy conservation. I gave you certain history behind what are the issues started, and then I've now come into hydro projects. Now, what should be inside this preliminary feasible report is the hydrological survey, the topological survey, geological survey, power demand, the discharge survey, the technical feasibility, and if any critical issues are there, that is also to be done. Being said this, I would just like to mention that I applied for hydro projects. We just identified a place in Kerala wherein they didn't have an electricity. It was a tribal living. They didn't have anything, and the only resources they had was waterfalls. Then we as a team from Karunya, along with civil engineers and mechanical engineers and myself, went and investigated that site. It was a huge waterfalls, and those people were residing very near to that waterfalls, but they didn't have electricity. Shocking, right? Till date, people don't have electricity. Is shocking for us because you and me have electricity. There are still people who don't even know what is energy, wherein the grid supply doesn't go there. So we did a complete study on the water, sand, people, what is the location, can an hydro project could be placed there, every study which we did. And this, I owe my gratitude to the students of Karanya. They helped us. They went and did the study. We, of course, we went there, but we had lots of people who are residing in Kerala. So we gave this project to them and they did a complete study. So their project was preparing the preliminary feasible report. So then we went on to the detailed project report. Detailed project report, again, they had to present, find out what is the discharge of water, because a small head won't be sufficient enough. There should be a pressure in the water, and then only we can take up with the hydro project. So they did the hydrological survey. They did the topological survey. Topological survey means they will get the meteorological data and they'll see the map. See, for example, you can't go and construct an hydro project onto the top of the hill, and if any rainfall comes, the hydro plant itself will be vanished. So we have to do a topological survey, and this is the map that I'm showing you. I got it from the Kerala government. They gave me this project site where it has been situated. You can see some red, blue lines and black lines. Blue lines are the streams where the water is flowing, and the area is, this is the project area which we have selected in Kerala, which is there in Idiki district of Adimadi village in Kerala. And there they had a very good resource of water. So you could see this catchment area. You can see the blue streams, blue lines, which has been flowing here. These blue lines is to show that it has a huge energy of water. All this forecasting data are available with us. Data are really available with us. But only thing is we should be able to take on energy conservation onto this. So this we call it as catchment boundary. Catchment means the area which is which is a high resource. So that you would have seen that blue lines and black lines. Blue lines mean continuous supply. Black lines means only during monsoon, because you need electricity throughout the year, right? You can't just like that stop it for some time. So if that's the case, you need a continuous flow of water. Then you will be moving on to blue lines. If you certain areas will have black lines, meaning to say that that will be only on monsoon. Now you see, this area is alone having continuous blue lines, meaning to say throughout the year, it is highly having a very good resource. So I'm not going into the details because I have shown my own project report. So I'm not going into the details of it. So the geological survey, the topological survey, the power demand, what is the head, the height, all these things was analyzed. At the conclusion, I will show you all these pictures. I will show you the site itself. And then a survey on whether the materials could be taken up to that place, the power evacuation, all these things were surveyed on. So all those things were a little bit on electricals. We also had civil engineers along with us. We even had the civil students. Again, I would like to show my gratitude to them. They helped us in designing of the wear and tank, distillation tank, head race, forebay, penstock, and for the powerhouse construction. All these things are to the civil structure. So they helped us in doing all these things. Now, I've spoken continuously for the past 10 to 15 minutes. One small question. Okay, you know that the electrical power formula, I've given you the formula. I have just made some changes in the power equation, increasing the discharge of water, reducing the head, or reducing the discharge and increasing the head. Excuse me. Okay, so just excuse me for that. I had a little cough and that's why I just muted. Hope you could see me now. And am I audible also? Yes. You can hear me, students?
Yes, ma'am.
Thank you. Now a small question for you, okay? This is the power equation which is there. When you talk about hydro projects, I explain the question very clearly to you. The water has to fall from a very height of 100 meters head or 90 meters head so that it comes and falls onto the turbine, electricity will generate it. So here, the water height is more, but even the discharge of water could be small. Next option is, the height is only this much, but the water discharge should be very huge. So I'm just asking you, when do you feel that the power will be generated more? Is it where you increase the discharge and reduce the height of the water falling, or decrease the discharge and increase the head? You just leave option 2. I am just giving you one option. Just tell me whether it is option 1 or option 3. Hope my question is understandable. Hope my question is understandable. If you have any doubts, you can just ask me. Do you have any answers, students? Do you have any answer for this? Any guesses? Or is it very hard? I will make my question simple. For electricity generation, the water should come and touch the turbine. So the pressure in which this water comes and touches the turbine produces energy. So I'm asking you, what is your view? Whether the height is important or the water discharge is important. Any guesses? Could be option 1 or option 3. Which option?
Water discharge is important, ma'am.
Water discharge is important according to you. Okay. Thank you, Abhinav, for that response. But I just mentioned about this project this student of Mumbai did. That was rainwater only. Rainwater is collecting from the terrace. So that would be little, but the height was 25 floors or more than 25 floors. So there, his discharge was less. The rainfall water could be lesser, but according to him, the project was the height only is concentrating. But anyway, statistics says that option 3 would be better because the discharge is 1/4, but the head is 4 times that option of that one. Because if the discharge is less, right, students, then the diameter and the thickness of the penstock is also less. The size of the turbine also will be less. Also, if the head is high, the size of the generator also will be less. So in my project, that is depending upon site to site, it might differ. In my project, I have taken up as option 3. Okay, now, so I've told you a little bit of electricals. I've told you a little bit of civil. I'm telling you about the turbine because I think turbine is the core part which I didn't speak to you. So I'm just talking to you about the turbines. Turbines, different types are there. I'm not going to the depth of it because it's not required. Okay, if anyone really working on all these things in future, maybe you can tell me at that time, I can take it up. But if I don't talk about the turbine, my presentation itself will not be whole, and that is why I just mentioning it here. Whatever I've showed in this slide is the different types of turbines that you can use for your projects. Based upon what project you can do, you can select the turbine. So it is according to Newton's third law, runner rotates due to the reaction. These are some of the pictorial representations which we have it in our own laboratory. We have different Pelstone turbine, cross-flow turbine and Francis turbine. I am now moving on to the construction and operation, but as of now it is sufficient if you know this alone. And again, now I told you for power generation, which formula you should select, right? I told you option 3 is the best. Now, for selection of turbine, I will just give you one formula. If you want to select a turbine, you have to select based upon the specific speed. No books will give you all these data, students, because since we did this project, we know all the hardships that we faced. So on what matrices you should select the parameters itself is a big study which we did for 1 long year. So that I'm putting it in a nutshell and giving it to you. So when you have to select the turbines, you have to see only the specific speed, which would be the speed of the turbine into the power divided by head. This is the formula. Later you work out all these formulas. If after calculating this specific speed, if your answer is between 12 to 30, use Felston. If it's 20 to 30, use Targo. If it is 20 to 80, use Frost Flow. If it's 80 to 400, use Francis. Anything about 350 and 1000 also, you can use Kalpan turbine or propeller turbines. Now, all these things are very important if you do an site investigation. So anything above 1500 also, you can use your Francis turbine, but there is no hydraulic turbine which is available for specific speed which is more than 1000. This is again a research topic that I'm putting forward to you. If you're interested, you can do this and it will be patentable. This work is really patentable, which is not taken up by anyone. So I have given you 4 different projects. I have given you 2 industry visits. This is the patent topic that I'm giving to you. Anyone interested, work this out and you can go in for a patent. So this is all onto the selection of turbines. Now onto the electrical part. So I finished about the site investigation. I finished onto the civil part. I finished onto the mechanical part. Now I'm going on to the electrical part. Now after this water comes and falls onto the turbine, after the generator is there, you have 2 types of generators. Either you can use a synchronous generator or you can use an induction generator. Synchronous generator, which will require DC or it will require a permanent magnet. Again, students, I'm not going into the detail of the construction because it's not required for you. So you can just note down that synchronous generators could be either DC or permanent magnet. So this is the constructional details with stator and rotor. Any motor would be having it. The rotor would be having the field winding, which would be wound rotor or silent rotors. This is a pictorial representation of the synchronous generators. And formula to find out the speed and the frequency. This is the formula which I've used in my project. And if you're using an induction generator also, you can go in for an induction generator. So there are certain differences between the synchronous generator and induction generator based upon the project that you're going to select and based upon what and sort of energy conservation you want to do. You can either select a synchronous generator or an induction generator, and that is why I'm just giving you the classifications between synchronous generator and induction generator. Students, I think this is not that very important for you, so that's why I've just scrolled the slides and want of time, I just made it up. Do you want any detailed explanation on this? Shall I proceed with my slides? Can I proceed with my slides or you want me to explain on to this? Shall I proceed with the slides? Shall I?
Students?
Yes, ma'am.
Yes, ma'am.
Okay, thank you, thank you. So I just wanted to know whether you wanted to know these details, but this details is very huge. I think I should talk to you for yet another 1 hour. If that's the case, I'm very happy to do, but within this span of time, I'm just concentrating how to conserve energy and what are all the possible researches that I can give it to you as a student. Okay, so these are all parameters of how we can select the generator and how we are going to transmit it. Now, what are the hazards? What are the issues that I faced when I took up with this power plants? Hydro plants has issues such as poor planning, unpredictable natural events, and the equipment failures. So safety and protection is a very important parameter that has to be taken into consideration. And that is a major parameter here. Normally, we have emergency stop switches because when we are constructing an hydro projects in that river or in that stream, fishes would be there, right? If you don't put stop guards or if you don't put any isolators, then these fishes also will come into the turbine and it will literally spoil the life of those fishes. In turn, people are also depending on fishery only. So those emergency stop functions should be really important. Certain structural measures has to be taken. Operational safety has to be there. And there should be proper valves, protection valves, which has to be fitted in every places. We have fitted chambers for flood protection. Because if any huge flood is there, it will fall on my turbine. It will cover my plant itself. It will cover my what to say, hydro, that area itself. The power outs itself will be gone if there is a flood. So the flood valve should be there. Then and we have to put certain valves in the power station also. Safety measures onto the spillways, because ungated overflow spillways are very dangerous, because they may be difficult to recognize the reservoirs and the boats. If any boat is going on, if I have to pull in that water, then the boat will come and fall on my turbine, right? So such sort of spillway safeguard measures also should be taken. Substation safeguarding and all these things, bridges, power lines safeguard, and more than all these things, it should not have an unmanned operation. Mean to say, it should have a skilled person, because where boaters, the electrical shock hazards which is associated with the substation near these dams are very obvious, because boaters or fishermen could accidentally make them contact with them. So that is also a very big point that has to be considered. But to start on with, you start with small hydro projects. That is my advice and suggestion that I'm giving it to you. But in case if you're going in for big projects, these safety measures also should be taken. Certain warning alarms, horns, sirens, all should be there, because children or people should not come and take bath in that water. So many things are there. So certain sirens and horns and lighters should also be kept as safety devices. Of course, some fences, guards also could be put there to see it. And moreover, no rubbish should be dumped into the water, because that water will be taken up onto the turbines for energy generation. So if any short circuit failures takes place, if any oil fires takes place also, that is a point of concern. So the picture which I'm showing to you is to show you that there were certain fire accidents in hydro projects which took place in Switzerland, Washington, Tennis, and Portugal. And the dates on when these accidents were taken up was given here. Anyone interested to know, you can Google and find it out. I will just place it as a tabular column. You can take a screenshot of the slide if required, and you could see and understand how fire accidents will take place in a hydro projects. I'm just giving you a fraction of a second for you to take a screenshot if required. Okay. Proceeding further, there was a very big fire hazards which took place at Sino Shukanke in August 2019, and more than 75 workers were trashed because of these disorders. There was one accident that occurred in Idiki Power House also in Kerala, and because of that, a potential transformer was lightened because unmanned laborers were there and they were not able to control it. And above all these things, there should be some safety equipment that has to be used when you move into the site on renewable resources. Now, the last few slides, I would just like to show you some research areas that you could work on. To name few, I told you that being people on physics background, you can work on some of the materials. You use copper for windings, you can change that winding, and you can use some other nanomaterials. You can also take up with the project which I told that Mumbai student has done, an energy conservation project. You can even use all of its sensors. If any road bumps are there, speed breakers are there, there you can keep this all of its sensors. And because of the frictional, that energy could be converted into useful energy. That is energy conservation. You can do projects on solar photovoltaic system. And so many are there which you could really work on and do projects on energy conservation. If you're in want of any topics also, you could let me know through your conveners. You can let me know. There are lots of projects just available, even on solar, even on wind, even on hydro. So many projects are there. Based on our availability, you can take up with the topics. Now, on to the conclusory note, I would like to tell you that present market situation should always is always demoralizing the young mind, saying that we don't have this in India, we don't have this there and here. No, we are all pursuing education on science. be it engineering or be it physics or be it chemistry. We are all science people. We have lots of science within us, but incorporate that science, give back that science to your motherland in some way or other, so that the energy crisis should not be there for our future. Today, we are fine. But what about 50 years after this? Think over your children's, your four children's, what are they going to do? If we could put some small seed today, that seed will come into a big plant in future in terms of energy. So we have a long way to go, and a bright future is ahead of all of us, with so much of opportunities in different areas, as I showed in this slide. But this is few. There are very many areas to invade into and do lots of researches. And one small part of mine is I am into entrepreneurship on innovation. I am the faculty tutor for entrepreneurship and innovation at Karana University. And I have been trained by NEN. NEN is National Entrepreneurship Network. And we have incubators and innovation center in our college, in which I am the faculty advisor there. I am helping it down. And I have been trained by them on entrepreneurship and innovation. So you can be entrepreneurs with the science education that you have. If you take up with the research, you could be a better entrepreneurs with this innovation, because the hosting person is on innovation cell of your university. So do research on science, which leads into innovation and entrepreneurship. And as per the lectures, I don't know whether you've heard to the speeches of our Honorable Modi ji, he always says that entrepreneurship is the need of the hour. We want engineers, we want scientists, we want physicians as entrepreneurs, so that the economy of the country will be really huge. So my very best wishes to you. And I would just like to show you some glimpse of the photos or the photographs which I did onto this government project. So formally, I'm concluding this PPTs, but my personal experience on government projects, as I told you, a proposal was requested to the financial assistance to implement a project. We took that site, and as I told you, the Hydro project is what we did. We wrote a proposal to the government, funding agencies, various charitable trust also we wrote. And finally, we identified the right funding agency was MNRE and DST. MNRE is Ministry of Science, Renewable Energy. MNRE is Ministry of Renewable Energy. And TST also had a technology division. So these two central government agency helped us in demonstrating a 15 kilowatt micro hydel power plant at Valara, Kerala. And the resources were entirely from MNRE, and it was hosted through the Energy Management Center, Trivandrum, Kerala. We faced a lots of challenges. Doing a work on renewable is not that easy. You have to, as I told you, you have to invade the sand, you have to invade the rock, you have to study the site completely, and you have to get the clearance from the government. It is very difficult to do the survey, but again and again, I thank my students of Karunya for helping me out to execute this project. And basically, we started this project in 2012. Then 2013, we went into DST. 2014, we went into DST. There was a change of government in 2014 in Kerala. Then again, we have to rework onto it. So many hardships were there, as I told. But above all these hardships, the learning which we had onto that project. This is just a glimpse of the challenges we faced. This is my team. You could see me also holding the umbrella as myself, and my whole team with civil engineers, mechanical engineers. We also invaded. This is the site there. We don't even had a proper road. We went there. We wanted to do something on conservation of energy. So it was a complete team who went there. You could see our students and faculties holding all those equipments. It was very hard to carry all those things. Not only students, faculty, old senior faculties also were there with us. We all have to take this path. And then you could see we are into actual a forest only. I mean, it's not a forest, but it was very hard. And thanks to all the professors who helped our students to take up with these challenges. You could see the site. It is a run-off river scheme. You could see the water which is flowing. It is very dense. we just stood in the place where the water is not that very dense, and we invaded onto this place. So we have our faculties and students standing along. This is just a glimpse, and we have the complete Valara team. We have to cross this bridge and then only go into that site. So this is the complete Valara team onto the entrance. We just took this photo, and then you could see the site. This is the finally approved project which was given by Government of India with a funding amount. And this is team members' names which I mentioned here. And this is the final achievement which we have done. And I would like to thank Energy Management Center Trivandrum and the faculties there for helping us to execute this project, and to the management of Karunya University for helping me invade into this project. So thank you, and I am done with it.
I request dear participants to unmute the audio to ask any queries for discussion.
Hope my presentation was useful to the students, because rather than talking too much of theory, I took up with little bit of research topics and my personal experience I've just shown to you. So if you have any clarifications required, you could ask me. And all these things are real-time works. We didn't do any bookish work. So I encourage all of you to take up with energy conservation in future. Any questions?
Ma'am, excellent session, ma'am.
Thank you.
Your session made us to travel with your project and could understand your efforts for it. We enjoyed the session, ma'am.
Thank you. Thanks a lot. But it was lots of hardships which we have put onto our projects. But my personal experience is, when we do projects on energy conservation, we should be very patient. It will not evolve the next day. So I encourage all the young people seated here and listening to this, take up energy as your projects in future, and you will get a real-time experience. So all the best to all of you.
Thank you so much, ma'am. Our students will take up projects and they will approach you soon, I hope, ma'am. Thank you.
Okay. Thank you. Thanks a lot.
Priyadarshini?
Yes, ma'am. Now I'd like to call upon Ms. Sukita of first year BSc Physics to propose a vote of thanks.
Good morning, everyone. It's my pleasure to express my appreciation to everyone around here. On behalf of Physics Department and Institution's Innovation Cell, I thank our revered correspondent, Sri K. Palanisamy Avarhal, and our Honorable Principal, Dr. N. Raman Sir, for their valuable guidance. I heartily thank our revered Chief Guest, Dr. Praveen Angel Michael Ma'am, Associate Professor, Department of EEE at Karunya Institute of Technology and Sciences, for her presence amidst the busy schedule. My heartfelt thanks for such an exuberant session, ma'am. We understood the importance of conserving energy through various conserving techniques. Especially, we clearly learned about the hydro energy and technology of extracting power from the water resources. Also, we are surprised to know about the need of energy and power capacity additions in the present era. We assured as a student community that we will learn and conserve energy in all the possible means. I widen my gratitude to all our earnest teachers and my beloved students who took part eagerly and extended their hands to make the moment complete. Finally, I wholeheartedly thank everyone who made this day a memorable one. Thank you, everyone.
Thank you.
Thank you, ma'am.
Thank you,
Let
ma'am.
us officially close the session, ma'am.
Thank you. Thanks you. Thank you.
I request the participants to fill the feedback. The feedback link will be open only for 5 minutes, so I request all the participants to fill the feedback.